All right, got a packed house. So a little bit more room, so if we get cozy and know each other, we can fit a few more people in. But thank you for joining me today. This is a presentation on Docker containers for network engineers. Is it an actual source of pain, or can we solve some problems with it? My name is Quinn Snyder. I'm a technical advocate with Cisco Learning and Certifications. Um, I've been working with network automation and development for quite a few years, and this is one of the ways that I can actually use Docker containers as a network engineer, not just for building apps. So to kick things off, we'll talk about what containers are and what they aren't, some of the technical bits and pieces that may or may not be obvious when it comes to the differences between containers and VMs. We'll talk about what it takes to build containers and some best practices, and then more importantly, most of the information that we see about Docker containers around packaging applications for delivery to some kind of audience. Most of that is to end users. You're doing DevOps, you're writing applications and deploying them into prod. But what gets lost a lot of times is how can we make Docker containers work for you as network engineers? Nothing would be complete without a demo, and by staying here, you also get access to all of my code, so you can take this back and use this in your own environment, and then we'll wrap things up. So containers, everybody's talking about them. They're a running, most importantly there, set of packaged libraries and binaries. So when we talk about containers, containers are runtime. If they're not doing anything, if we're not having them actively running, they're called images. That sounds pedantic, but it helps clarify things when we start getting into the nitty gritty. So running container, if they're at rest, they're images. So we build images, we run containers. They're a standardized runtime environment. So like if you kind of like think of a virtual machine that's actually doing the container instantiation to abstract the underlying operating system mostly and ensure portability also mostly. We'll get into some of the bits and the bytes of why they're not 100% portable and how we abstract that OS in future slides. They're lightweight and they're generally faster to run than VMs. So I remember back in the day, if we had to have, we had our corporate image on our Windows laptop, but when we were doing network testing, we needed things like iPerf, we needed Wireshark, we needed a bunch of other tools. So we'd install like a Linux VM that we could start gathering all that stuff. But back in the days of spinning Rust hard disks and maybe dual core CPUs, it took a long time for those things to run. Now I can stand up a whole development environment in a matter of seconds using a container. The big difference between containers and VMs is illustrated here. On the left side, we have an actual container runtime. We have our hardware. We have our operating system that sits on top of that hardware. That can be Windows, it could be Mac, it could be Linux, it could be BSD. It does not matter, mostly. You see there's a lot of caveats here. This is the great part about it. From there, when we install some kind of container runtime, whether that's Docker, whether that's Podman, Container.io, there is some socket access directly to the kernel space in your operating system. This is why if we run things like Docker on top of Windows, we're installing a VM using Hyper-V or some other virtualization software to actually get you that shared set of libraries and runtimes. Because you need that socket space, because as we instantiate containers on top of that, signified by apps, you think of an app as a container. As we instantiate those applications, we're not having to create an exact copy of every single system binary into that application. We're providing kernel access to what we have underlying in our operating system up to those apps. So then all we have to worry about is the specific binaries and requirements and libraries to run that application. That's why they're fast. We're not having a whole bloated operating system. We're just sharing what we need to in order to make sure that app can run within our kernel space and our operating system. On the right, we have a traditional type 1 hypervisor. So this is type 1. So think of your vSpheres, the ESXis, that kind of thing. For there, we have hardware, we have our hypervisor, and then we have a barrier of isolation. Those VMs that sit on top of that type 1 hypervisor have no idea they're running on a virtual environment. Yes, we present things that make it apparent, virtualized graphics, virtualized sound, virtualized network. And yes, before we start to get into the details, there are things like SRIOV, DPDK. We can provide some very specific and isolated access to that direct hardware. Graphics processing is another one through that type 1 hypervisor. But aside from that, these VMs have no idea they're running on that virtual OS. On top of that, for every app that we want to run, we have to have a full heavyweight operating system. Windows, Linux, some kind of Unix variant if we chose. So we have to have that entire set of the libraries and Etsy and all the runtimes. If we're looking at Linux, we have the whole System 32 stuff. If we're running Windows, all of that has to be copied over. So we've got gigs and gigs of storage being used just to run that operating system before we can even install our app. And then on top of that, then we have to worry about the specific dependencies for that app. So those are the differences between containers and VMs. The big difference here is shared fate. The biggest, not necessarily the biggest, but one of the larger concerns around using containers, especially in production applications, is the fact that it is possible to escape out of a container and compromise the underlying operating system. There's been some breaches around unsecured credentials being leaked in like Kubernetes environments. There's app executions and chroot jails that have been escaped in containers. So container security does become a larger issue. And that's why we see things like SBOM and static code analysis being used very heavily in like our CI/CD pipelines to ensure that our containers are actually secure, because you can escape. It's much harder to do that if we're looking at type 1 hypervisors, because of the way that they're built, and they abstract everything away from it. But with that complete abstraction, we have much heavier weight and much heavier runtimes. But no separation, no problem. It's actually a good thing. Because we have that shared kernel space, we have those quick instantiation times. My operating system, my underlying system is already booted. Just provide access up to those libraries into my container and we're good to go. That app just needs to initialize. There's also no redundancy in this, meaning for every VM, if I have 10 Linux VMs running on a server, I have to have 10 copies of Linux running on that server as well. So we're using gigs and gigs of space just to run those applications. With a container, because I'm only worried about the specific binaries that run that application, much smaller in size. So there's so much more room for activities if to throw back to a movie reference. Now, what I said about portability being mostly a thing, Windows containers do exist. So Windows Server, like IoT Core and things like that, you can actually containerize those things. The problem being, going back to our previous slide about the shared libraries and shared fate, I cannot run a Windows container on my Mac because I don't have those underlying libraries that support the instantiation of that container. So for this time and this time only, I will let Windows users have this one. You do have a little bit more flexibility than a traditional Mac or Linux user, because you have the ability to run multiple types of containers. So how do we build them? We use a Docker file. For anybody who's studying for like your Dev Associate or Dev Core, Docker files are a pretty important piece of that. When I write a Docker file, it looks very simple. I create an image from defined steps. So everything, I know for those in front, I know the LEDs are a little bit hard to read. Everything in yellow is written is a specific step. So that's a verb that we have to do something. So verbs trigger actions, actions create layers, and then the packaging of the layers creates an image. So if you think of this as a cake here, this is the very bottom layer of the cake, and it starts building on top of each other. So if I change something down here, I can reuse all of these existing layers, and the build time is much shorter by changing something down here. If I change something at the very top, that layer is no longer valid, which means I could have knock-on effects further down the chain. That build time becomes much longer as I change that Docker file. But you can see it's very simple. We're copying in this example, we're copying requirements.txt. We're setting our shell prompt. We're installing some packages using APK on Alpine. We're installing the requirements from Python pip, and then we're running bash as our shell at the very end in directory /mycode. Now, don't do what I did here. This is a much older Docker file, but it served a simple example. Alpine used to be the de facto standard for creating container images. It was light, it was small, it was fast. The problem with using Alpine is that it comes with a lot of baggage. There's a lot of tight versioning requirements. It doesn't have a lot of the standard libc libraries that come with like Ubuntu or a Debian-based or Red Hat-based image. So you can run into some very weird things that happen, especially with things like Python, where we have pre-built wheels that we can't use in Alpine, but we can use in Ubuntu. So you have to build it and have all of the build time instantiated inside that container. So I would suggest using Ubuntu or a Debian or a Red Hat-based image rather than Alpine as you start building your containers. It's good for a science experiment. Don't get me wrong. Everyone should build and have to go through dependency hell again using an Alpine container, but it does create a lot of frustration. And like I said, the order matters in how we do this. But if we noticed, it's all just Bash. It's amazing how much technology that we still use today that's brand new that we've been using for 30 years. How many have built CI/CD pipelines before? YAML wrap Bash. Docker files, that's Bash. It's all Bash. It always will be Bash. It's just we should accept it. So Bash scripting becomes very important when we deal with anything around container build times. So now that I've rambled on for about 10 minutes, how do we make containers work for you as a network engineer? We've talked about the process. We've talked about what they are, but how do you make them work for you? So like I said, a container uses those shared libraries from the underlying OS, but we can install things on top of that that creates a little bit of separation. So if we think about when we're dealing with development environments, so Python, Ansible, Terraform, Go, we're building these tools for our net DevOps tool chains. A lot of times we have to do some very heinous acts on our laptops to make those things work. Python virtual environments. We might use PyEnv or TFM to source and make sure that we have the proper versioning for regression testing and things like that. And then on top of that, how many people have forgotten to switch into a virtual environment when they're writing Python code? And all of a sudden you've got like 10,000 different packages sitting inside of system Python. And you're like, oh, I don't even know how to fix it. So you wipe it and start all over. If it's in a VM, if it's on your system, your actual main system, maybe that's a wipe and restart because so many things depend on it nowadays. That creates a lot of issues, a lot of potential problems. But if we have all of those things set inside a container and our containers are ephemeral and we can wipe them and treat them as cattle, not as pets, we no longer have to worry about those same issues. We package our development tools inside of a container. We instantiate them when we need them. We use them when we need them, and we destroy them when we're done. Our system is untouched. We can have whatever we need to inside of our actual laptops or our servers, and then we have that ephemerality when it comes to using those tools. Plus, if I build a container, and I did, and I share that with you, which I will, you can take those containers and run them in your own environments. So you hand someone a Docker file, you hand them a container image, they can install that on their local system, and they can use the same tools that you were using to the same effect. There's no longer, I think I even have a sticker, it works on my machine, I'm sorry that it doesn't work on yours. There's no more problems like that. They are more convenient than VMs because we're not talking about having an M2 drive that's plugged in that we're swapping sneakernet stuff. It's a simple text file. But we do have to do some other stupid human tricks to interact with them. For anybody who has run Docker containers, especially when you want to get an interactive shell in a Docker container, you do docker exec-it/bin/bash. Maybe we have some environment variables we want to pass through. That becomes a long text string to remember, but I'll show you through some more heinous acts how we actually get that to be much more simple when we start running those containers on our systems themselves. And I knew I could make this work. For those who have been around the block a little bit, you might have used some built and compiled some programs from source way back in the late 90s, early 2000s. At the very bottom, you have that /configure, make, and make install. That was GNU make under the hood. That was building things based on some predefined environment variables that were in a make file, that was compiling that software for your system, generally using GCC, and installing that into your binary path. However, we can make GNU make do other things for us. And we'll see how we can do that using phony targets inside of GNU make to launch our containers automatically. So we don't have to worry about typing all these difficult shell scripts. We can type make, our container name, and it runs. So with that, we've got about 15 minutes left. This is I'm going to have the demo here in a second, and I will be around afterwards. If you want to take a picture of that QR code, that will take you to my repo that has the sample code PDF of the presentation. And I believe I have a README, but I might need to update it a little bit because there's some changes I had to make last minute for the sandboxes. But all of that will get you started with what I'm going to demo here today. Any questions so far? Good? Sweet. Okay. So let's start small here, and I will look at this Python 3.7 Docker file. So this is just a standard Debian Bullseye Docker container. This is actually from the Python Docker Hub repository. And there's a lot of things in here. Basically, all I'm doing is I am installing Python 3.7 inside of this container. Now, I'm doing some edits, and this is a little bit more complex, but at the very bottom, all I've really done is set up these pieces here. So I'm changing my shell so I know what container I'm in. I have a directory called root my code. I'm moving into that, and then I'm running bash so I can actually execute things inside of that file. That's the big piece. So I have done that for Python 3.7, and I also have done that for Python 3.10. We see where we're going with this? I don't need to worry about having a virtual environment. I don't need to worry about using pyenv or maybe using Python 3.6 versus Python 3.7 when I run this from my local shell. If I want to run some Python code, I run my container, and I can do all of my netmiko, all of my automation, all of my testing across different versions right here from my Docker container. So I've got Python 3.7 and Python 3.10. On top of that, how many folks have used Ansible? How many people have had to refactor your playbooks multiple times because of the Ansible version that you're using at the time? Gets a little frustrating, I get it. Again, if I build a container with Ansible in it, in this case, Ansible 2.9 versus 2.10, there's a big shift in how we use collections between those two Ansible versions. I package that Docker file with Ansible 2.9 in it. I ship that to someone else. They also have Ansible 2.9 now. They don't need to worry about doing the pip install. We don't need to worry about virtual environments or pipx or anything like that. It's in the container. We run our code. When we're done, we exit, and we kill that container. More importantly here, we can get very nested. And so what I've done here with Ansible 2.9 is I'm using Python 3.7. So that Python 3.7 container that I built earlier, I'm pulling from that and building Ansible 2.9. I'm setting my shell here, and then I'm installing Ansible as well as a collection, moving into root my code, and then giving me a bash shell so I can interact with that. Same thing with Ansible 2.10. I have Python 3.10 setting my shell, copying requirements. Now you see here I have a slightly different step because 2.10 Ansible requires me to install different collections for Cisco iOS and Cisco NXOS to interact with my devices. So again, I've shipped my dependencies with my Docker file. You don't need to worry about installing those collections, or I can statically set the version of those collections in that Docker file. There's no longer, well, it works on my machine, I'm sorry, we can't use it on yours. It runs in the container. Everyone has access to the container. And the final piece of all of this is this makefile. So again, if you're not used to Docker operations, it can be a little bit intimidating when we build and run containers. I've set my shell to make sure I'm using bash because I'm one of those weirdos that does not use a POSIX compliant shell. I use fish, so I have to make sure I'm running bash. We set these phony targets, and without getting too deep into the GNU make ins and the outs, phony just means don't worry about the files that are created as running those containers. Just run the command as you would normally. If it exits clean, if it doesn't exit clean, don't worry. I don't need to clean anything or move it around. So we have phony targets built for each of those. Now here are my build stages. If I just type build Python 3.7, 3.10, Ansible 2.9, or 2.10, it'll execute those Docker build commands just as I was on the shell, and it will create the appropriate Docker container image, and then I can interact with it as I wish. Now, if we've run Docker containers before, we also know that the running commands can be a little bit intimidating. So what I've done is I do the docker run IT. I'm running in privilege mode. I have a terminal environment variable set there to make sure I have color in my terminal because I like colors. And then I can also set mapped drives inside of that. So within Docker, I have the ability to share folders between the container and my actual host system. So with this, not only can I ship the container, I can ship an entire repository. You clone down the code from your source code manager, you copy that into your system, you execute the build, and when you run, if you have any Ansible playbooks, any inventory files, any Ansible.cfgs, any Python code, it'll run from that folder because we've mapped it. I don't need to worry about the syntax. I've set it all up so it's automatic. And now I'm sure you are all waiting for the proof to be in the pudding. I've already built these containers. Built these images. So there's not a whole lot if I was to do a make, let's see, make build Python 310. Let's do this, Python 310. It's not going to show anything very specific because I've already built those containers, or built those images. But it's going to run the build command. Oh, that's actually going to do it. Sweet. So right now, you can see I've got those layers. 1 from 8, I'm doing all of the building that's called as part of that, the build pack there. It's extracting all those things. I'm creating all the SHA files that are there. This is creating a layer. So what you'll see is eventually this will start changing 2.8. That's that second layer that's there. 3.8, and let me scroll down so you can actually track this. So there was that. We're currently on 3.8 now, so we're doing the wget Python, so we're running this command here. So you can see that each of those is translating into a layer, and there are things that are involved behind that. I will create a new here while that's building, so we don't want to waste the time there. Clear. So now if I do a make, we'll do Python 3.7 here. I've run the command, and now I'm in a Python 3.7 container, and I've set that based on my my shell script or my PS1 file that I have, or the PS1 command that I set in the Docker file. Just to show you that there's nothing up my sleeve, if I do a Python version, you can see I'm running Python 3.7.16. If I, just to show you here, if I'm on my local system, I'm running 3.9.7. So you can see that it's actually different. There's different dependencies, different modules. We can do a pip freeze here to see that there's probably nothing installed in pip. And I have a bit of Python code here, this version.py. I'll pull that up here, which is just doing some real basic Python stuff. It says gather the current date and time and give me the Python version. So I can do Python version.py, and I now have the current date and time that's being, and you can see, again, nothing up my sleeve. It is the current day. It is the current time. It may be in the US format. I apologize for my European friends. And the appropriate Python version. Now, more importantly, if I exit out of here and do a Docker PS, that container is no longer running. So I have the ephemerality where I can interact with my code. It's saved back and forth between my system and my container. But when I'm done with it, I can exit and there's no trace of it on my system. It's no longer running and taking up those resources. Great. I know that I said for network engineers, and a lot of network engineers are hesitant for Python. Let's talk about Ansible. So if I do make Ansible 2.9, you can see that this is going to be built on Python 3.7.16, just as I declared my Docker file. And I also have a folder called Ansible. And in that Ansible folder, I have this YAML file and then a config and an inventory. So let me expand that for a second here. And I'll look at this YAML file because that's the most important piece here. All I'm doing is I'm gathering some facts from the DevNet always on sandboxes. There's an iOS XE sandbox and an NXOS sandbox. So I can run my Ansible playbook here. And I'm going to run it slightly verbose. And it's going to go out and it's going to gather the facts for those two different devices and spit them out into standard out. So we can actually see that I'm connecting using my container through all the Docker networking pieces out to an always-on sandbox using Ansible 2, in this case 2.9. was it 2.9? Oh, I don't have it. I can Ansible version 2.9.27. So I have that specific version of Ansible running, and I'm gathering the facts here. Now, if I do, again, I'll do an exit here, and then I will do a Docker, or sorry, a make Ansible 2.10. And here, Ansible version, I'm running 2.10.17, but I have a very similar, in fact, I believe it's the same file here, where again, I'm just gathering facts, but you can see I have to do something slightly different. I have these tags to say, use these pieces with the appropriate network OS as part of the new the refactoring that happened with 2.10 and Ansible. I'll do an Ansible playbook. Oh, wait. Let's get into the Ansible folder first. It'll go out and it'll run that same command using Ansible 2.10.17 or 2.10.11 or whatever it was that I said. So again, I have portability between my Ansible build environments. So all of my network automation that depends on a specific version of Ansible, I don't need to worry if you've done a pip upgrade. I don't need to worry if you have it in a virtual environment. Everything is running directly in the container as what intended. So we have complete portability across all of our code. So pretty handy. I don't need to worry about anything else than having Docker installed on all my hosts. And again, I'll do a Docker PS. We have no trace of it when we're done running. Any questions so far on any of that? Perfect. Oh, yes. Yeah, that will. There will be a PDF of the presentation inside that repository. I know I covered a lot and I talk really fast. So, and then my contact, you can either reach me through at QSnyder on Twitter. I'm on LinkedIn. QSnyder@cisco.com was my email. You can reach out to me there to answer any questions that you may have there. So with that, I'll wrap up. Please fill out your session surveys. They will be available for these Cisco U sessions, which is something new. For those who were here last year, there were no surveys. This year, we do have them. I enjoy seeing your feedback. Tell me what I did, good, bad, or otherwise. You fill out enough, I believe you get a free t-shirt. Please continue your education. So we have a ton of stuff here, learning certifications. If you're interested in learning about the DevNet Associate, DevNet Professional, or any DevNet specializations, that's more the network programmability, we can talk about that, or any other cert you may have. We have the CML demo back there. If you're worried about, okay, great, I have all this automation, where's some targets? We can talk about CML and using that for net DevOps. We have a ton of other education and stuff going on there. And with that, oh, and finally, I'd be remiss, if you have not used Cisco U, Cisco U is our learning platform. We have a ton of free tutorials, including ones like this and others around network programmability, network automation. That's on an automated slide. So if you're interested in Cisco U, we have demos back there. Take the QR code u.cisco.com. And with that, thank you very much.